Alright, we'll just still make these videos by pages. So this is the first part of the study guide, and this guy is, yeah, let's just do it. The limit as we approach 0, so we're not going to infinity, so we don't have like the end behavior models to work with this guy. The only thing we can do, we can't substitute, so what we'll do is we're just going to factor and just see what happens. Alright, so we've got 3, I see an x squared that we can take out of everything. So the limit as this guy goes to 0, but I'm going to take an x squared out of everything so that I get a 3x to the third plus 12. Okay, I'm going to take out an x squared in the bottom as well, and I get a 5x to the second plus 6. Okay, now we've got these two canceling out so that we can actually plug in a 0, and you can see that if we substituted a 0, we would be left with 12 over 6, which is 2. So your answer there is 2. The next one. Now, we can't factor out anything there that I see. We're going x minus 3. Okay, I'm going to actually, you can't really do anything there. This guy has an asymptote, so nothing was factored out. So all we can really do at this point is just think to ourselves, okay, he's going to infinity or negative infinity for sure. So we just have to figure out which one it is. So let's pick a number to the left of 3, and so to the left of 3 would be like 2.9. Now let's just see if it's positive or negative. And let's see, 3, 2.9. This would be 2.9 minus 3. So that would give me a negative on the top and then a negative on the bottom. So it looks like this guy is just going up to positive infinity. So the answer would be B. Okay, so the IVT doesn't promise a lot. You know, it just promises that there are certain values between certain, endpoints. Okay. So if we let f be the function that is continuous on the closed interval, okay, from 3 to 5, okay, so I guess I could draw a picture here. Let's go 3, 5. And then f of 3 is 9, okay, and then f of 5 is actually 22, so I definitely didn't draw that to scale. Alright, so which one of the following is guaranteed by the intermediate value theorem? Now, I don't know about you, but I find this sketch very helpful, especially when I have to comb through possibilities here. Okay, f of x equals 11 and has at least one solution in the open interval. I'm sorry, f of x equals 11 has at least one solution in the open interval. Now, the reason why, when we say one solution, this is the solution. Does it actually equal 11 at some point? And we can see that between 9 and 22, it's definitely going to pass through 11. So that actually is a go. So this is a yes. Okay. But let me just make sure that these other things are not a go. Okay. So f of 4 is 13. Are we guaranteed that? No. This guy could have dipped below here. Okay. He could have actually dipped below 9. This is all that we have. Okay. But we do know no matter how far this dips, okay, he eventually has to go here. So passing through 11 is for sure. But we don't know that it passed and got 13 at 4. It could have happened somewhere else. F of x has at least one 0 on the open interval. We are not guaranteed that at all. This guy could be just a straight line. So that's a no, that's a no. F attains a maximum value. Well, right there, maximum value is not part of the intermediate value theorem at all. So we can just forget about that. All right, so the answer to 3 is A. All right, now this guy, man, I feel like we did this already. I'm going to go ahead and just, did we do this together in class? We did, right? Because we got 6 seconds. Yeah, we did. We did do this in class. Okay, so I'm going to go ahead and just, now there's another one like it on the other study guide too. Let me just do one more here. We did this one too together in class. We said that it's got to be these two together because g of 2 is definitely, wait a minute, g of 2 is defined, so it cannot be 1, so that means it can't be that one. And then we talked about whether or not the limit exists, and that is true, and of course, because that is defined, that number does not equal this guy, because clearly this guy's undefined, so they can't equal that. Alright, so we knew that the answer there was D. 6, I might just do 2 pages for this one. Alright, so it's shooting off to infinity. Okay, now that's good, because this is an end behavior model. So I'm looking for the highest. Degree, and I can see that this guy is to the 3rd power on the top, and this this guy is also to the 3rd power on the bottom. Perfect. When it's the same degree, I mean, it's almost criminal to make this so easy, right? Okay, now this guy. Now we are going to negative infinity for number 7. So let's see here. All right. Let's see. End behavior model. Okay. So it looks like we've got the square root of x squared, and it's going to be over negative 3x. Now we would say that this is bottom heavy if the square root wasn't there, but because the square root is there, what I've got is I've got a negative 3x over the absolute value of x. Okay. Yeah, let me rephrase that. So what we've got is this is the situation here. Okay. So what I want us to do is then, if you can't really, I would not cancel the x's out. What I would do is I would put a very large negative value in each. Okay. So watch what would happen. Okay. Negative 3 times a very large negative number. Okay. I don't know. Let's just do that. Okay, but then we're going to take the absolute value of that very large negative number as well. Okay, and you can see that once I took the absolute value of that guy, he will become positive, and what you would have on the top is a double negative. Okay, so what we've got then is we actually just have a positive 3. Okay, positive 3. Okay, positive 3. It would be a positive 3,000 divided by the negative 1,000. Okay, so D is your answer. Okay, so yeah, watch out for that. That is an absolute value. So that guy is not going to matter. So what I would do is I would not cancel them out when you see an absolute value. They're so tricky. Okay, so given this function piecewise function, where are we at? 9 minutes. Given the function capital H of x equals this piecewise function, which of the statements is or are true. Okay, so these are what kind of make this like an AP style question, because you've got possibilities here, and these are always sinister. So watch out for that. Okay, so we've got this guy, and so what I don't know is I don't know if these guys actually connect. This is a quadratic and this is a line. Alright, so let's see, if we plug in 2, that would be 4 minus 6x negative 2, and then 2, that's negative 1. So these guys do not actually connect. So what we can definitely say then is that when we get to this one, when we say the general limit, it does not exist. Okay, that does not exist. Can we say that it's continuous? We can't even say it's continuous either. Okay, because we know that when we plugged in here, that was a negative 2, and this one's a negative 1. Okay. So now we only got one possibility. It's either going to be this guy or it's none of these. Okay. So let's see. If we are coming from the left, well, yeah, we already did that one. We're coming from the left. That's this guy. When we plug in a 2, we already said that it was negative 2. So coming from the left, we're okay, because this here says, hey, by the way, come from the left. All right. So it looks like A is our final answer for that. Okay.